Okay. Good morning, good evening, good afternoon, good night. Hello everybody from wherever you're at. Thank you for taking the time today to join us on this session. I'm going to talk about the architecture of a serverless database. This is something that we've been working on really for probably about a year and a half. We've been building a database there at Cockroach Labs for a while. But to actually take what we had built and turn it into a serverless application is really what I want to focus on today. Hopefully this is a conversation. Sure, it's going to be about our database a little bit because I think there's some unique challenges that we saw with our particular software. But hopefully there's some takeaways here in terms of a general approach and in terms of how we think about making things serverless and is it right for whatever application you might be building. And so that's the goal here today. But just a little bit before we get started. There we go, slides. Hi, my name is Jim Walker. I am principal product evangelist here at Cockroach Labs. I've been with Cockroach for over 3.5 years now. I first met our founders and Spencer Kimball in particular about 5 years ago. When I saw what was going on here, I couldn't unsee it. I was working at a company called CoreOS at the time, kind of deep in the whole Kubernetes and distributed systems thing. And what I saw here was just truly phenomenal. And I kind of really wanted to work here. And here I am a couple years later, still here going at it. I kind of loving what we do over here. And hopefully some of you are using CockroachDB. If not, hopefully this will give you a little bit of insight into what we do and why our database is a little bit different. But again, what I really want to focus on here today is kind of serverless and what does that mean for kind of app development. This session is intermediate. I'm not going to get deep into the guts of the architecture. We're going to go down into the storage layer and how we do distributed execution and some of those things. So it is a little bit more advanced than beginner. Definitely kind of dive into some of the distributed concepts. But then again, listen, I'm not expert. I haven't built a database. I've used a whole lot of databases. I'm curious. I love technology. I think this stuff is cool, honestly. And hopefully that comes out in this presentation. If you talked to me about, I guess, probably a year ago, I was probably a doubter around the concept of serverless and serverless technologies. I guess I didn't really get it. I didn't really kind of see the really what was going on. And fast forward, here we are a year later. I'm a believer in this stuff. I really do think that some of the concepts here, when applied to software, get really, really powerful because the value that they can actually provide is truly tremendous. I think one of the reasons I kind of love the concept of serverless and some of this stuff is I just think there's not enough talent out there. I think, as engineers, as developers, as architects and operators, I think we're all in a good spot right now because there's not enough of us to go around. And, I think the promise of serverless does some things around automation that brings things to new levels and really kind of, helps us move quicker, helps us to, deliver in ways that we haven't been able to deliver before. And so we'll talk a little bit about serverless. And I'm a believer in this stuff. And so we're going to get a kind of high level context around these concepts. So, but as always, please do ask questions, chat, QA. If you're in YouTube, I know there's a way to, I think in just the comments or in the chat, if you throw questions in there, the team will put them in this platform for me to answer as well. So gosh, by all means, please do ask questions. I'm happy to take them along the way. I like them in line. So if you want me to correct anything, I have about a half hour of material, maybe 40 minutes, half hour, 35. So questions are great. We have time. But again, thank you all for joining. If you want to reach out to me, I'm just Jim at Cockroach Labs. You can always find me on Twitter and all the other places as @James. So, all right. So let's get into this. Serverless. I find it to be a misnomer, honestly. I don't like the name, but honestly, that's what we're stuck with, and that's okay. But if I think about serverless, I think of it less as a group of technologies and more as an approach, more as a method in which we think about architecting things. It's kind of like how wireless was applied to an old paradigm to make it something new. When I was a kid, we had a phone just like this. In fact, it was black and everything. It was the analog phone, right? With this twisted pair of copper cable coming into your house. Thing was reliable, but dial tone, right? And then, this concept of wireless was applied to the phone so we can do new things with it, right? if you think about the term electric, well, I can troubleshoot the car on the left. I know everything in that engine. I like my current car is the one in the middle. I don't know what the hell's going on there. We made so many advances, but man, electric, when applied to a car, it's still a car, right? And our software and the concept of a database is still a database, but applying these principles to it allow us to do some different things to it, right? And creates things and show things in a different way. And so when I think about serverless and I think about serverless computing, it really allows us to kind of build and run applications without ever thinking about the back end. And the reason I think serverless is a bad term is because it's not just servers. I'm talking about load balancing and networking and like all the complexities of back end infrastructure. It's really this computing paradigm that says like, let me not think about server management. And in so doing, it needs to automate scale. It needs to be resilient. It needs to be on and available all the time. But most importantly, I think one of the key things about serverless that gets really interesting for me, I don't want to pay for what I don't use, which leads to this whole kind of concept of how do we all become consumption based in terms of how we consume whatever it is that we're doing. And I think serverless and these concepts of serverless allow us to do that, right? And I think we start looking at these we start applying these characteristics to the software that we're building and what we're kind of doing out there in this new paradigm. What does that look like? Now, I think serverless is being used as a term right now. I kind of think of like 3 different areas of how people are using these things. Like there's serverless compute, like there's a platform, it has a bunch of infrastructure and I just use this and it's like, great, I only get charged for what I use. Lots of companies doing this. The cloud providers all have like options here. I really love what the Google Cloud Run team is doing. Take a containerized app, throw it at Google Cloud Run. It's going to automate scale up and down. Like as you get more traffic, it's going to actually deploy more instances for you. It's got a pretty good UI. Like Cloud Run's pretty awesome, actually. But I think of that as like serverless compute. And then I think there's this whole world of these companies that are doing like serverless functions. And I think about like Cloudflare is doing this. Like if you think about, Netlify, right? And so it's like this event-driven functions where developers kind of write a function, they throw it into a directory and it's deployed. And it's just this function that gets deployed on infrastructure and used, right? And I think, Google Cloud Functions are doing it. AWS Lambda is like this. Like I said, Netlify, there's a lot of companies that are doing this. And I think it's like taking these principles and using infrastructure in a way that's very easy. So I don't even have to think about this stuff, right? And only use and only pay for what I use. And then there's this whole concept of like serverless app development where we're kind of pulling all these things together. And I think there's going to be, a next generation of companies that are building like these next generation like serverless app development platforms where you're just coding and all of a sudden like everything's deployed and it's great. It's just working. I think we're moving in this direction. But to me, like the common theme across all of this really comes back to automation. And I think automation is just one of these key concepts that, as an industry, as a member of this community of developers and architects, automation, I think, is really what's going to drive the next 5 to 10 years of what we're doing. There just seems to be, honestly, it's really difficult to hire people. And the more we can automate things, the better off it's going to be for number one. But I think through automation, we get these efficiencies. If you think about the term like DevOps and how that became SRE, really the key shift there is really around automation and how we're measuring success of things. And so I think, serverless really is the ultimate delivery of, automated compute and automated kind of infrastructure, if you will. Right. But when we take these concepts and we apply them to a database, we get a couple more different challenges, if you will, because a database is a unique entity. It's funny. I was talking to my friend Dan Goodman. He's at Ultimate Tournament, and Dan was saying, all of our applications are nothing but the material that's between our users and a database. I kind of agree with him, but then again, I work at a database company. But if I think about its serverless database, and what does that actually mean? If I can apply these principles to a database, well, there's a couple more requirements you have to add because, a database is not a simple concept, right? Like, are you doing transactions in that? Different types of databases, for our case, it's, do you have the relational model? what does a relational model mean and consistency mean when I start to truly become serverless? Because is serverless mean a single region, or does serverless mean global or multi-region? What is that, right? And so what does geographic scale mean in these concepts? Because a lot of people go out and implement databases and they'll say, oh, I want an active passive system. They'll set up, a primary in one region, a secondary in a whole other region. And then, when one fails, it fails over to the next. Like, okay, what does that mean in a serverless world, right? All of that needs to be automated as well, right? The resilient nature. I think of resilience as a function of scale, right? And honestly, all these really things come back to like, okay, if serverless is going to be scalable, well, it can't be scalable to X. It's got to be scalable to hopefully infinite, right? And when you do that to a database, there's some very discrete issues that pop up, and we're going to talk about some of those and kind of how we're solving those. I mean, I think the core of what we've done as a database is really kind of part of that, right? So when I think about serverless and I apply it to a database, just as I was applying wireless to phones or electric to cars, when I think about serverless and I apply it to, a database, well, we end up in a wholly new world. You end up in this kind of distributed systems world where these things do scale in certain ways. I think about, the advent and the popularity around things like Kubernetes, the popularity around all the distributed, like think about like Vault, think about like all the tools that we're using, our next generation infrastructure, it's all built around distributed systems. So how do you get a truly distributed database? That's how you actually get to serverless, right? And so for us, we think it's interesting, and data, is difficult to do. How do you auto scale a database across multiple different regions? How do I place data close to users? Because you know what, the speed of light's no joke. How do I guarantee, transactional latencies that are going to be sub 50 millisecond? Ultimately, all this needs to be kind of infrastructureless, right? And so when I start to really think about a database and what it means to serverless, I don't want to be myopic and think about a single region. Let's think about what this means truly serverless to infinite degrees or near infinite. Infinite's a bit of a weird a mark out there. I mean, there's always limits to everything in a physical world, right? So, all right, so this is what we're after, right? How do we just allow developers to just build? Like, I want them to have a relational database. I want data to be guaranteed correct. I want you to be able to code against an API. This should just look like Postgres, and ultimately we're going to give you a free tier, but we'll get into that. This code against an API thing, I think, is what gets really interesting. If I can have a serverless database where I don't have to worry about the operations of this thing, starting it, managing it, upgrading it, can I just do online schema changes without issues, without bringing it down up? If I don't have to touch the database, this thing's truly serverless. How do we actually really, really long-term vision goal think about data and databases as a simple SQL API in the cloud? And if we abstract everything back to that simple statement, SQL API in the cloud, how do I interact with the database the same way as I worked with any other dev tool kind of like API? Well, is that in a single region? What are the latencies? Where does data live? How does it, like, all those things need to be solved? And I think that's what we're doing here at Cockroach, right? Because we built a distributed database that does lots of cool stuff. And I'm not going to get too deep into that. But when we thought about making our database serverless, well, we said, okay, what are these requirements? Well, we have to automate scale, both up and down, for both not just data, like the storage part, but number of transactions, reads and writes, right? It needs to be consumption-based billing, right? Because you're only going to pay for what you use. And if we're going to make it kind of free for everybody, well, we have to be really careful in our cost of goods sold, right? So we're going to spin clusters down to zero, right? How do you spin down so that people don't have to pay for things? But then again, they're going to start again, so it has got to come right back up. And then, for us, when we created, our serverless beta, it's multi-tenant, right? We could probably do this for a single customer too, eventually, but multi-tenant, so one database across the entire globe. We're talking about SQL API in the cloud with, 7 endpoints across the planet, guaranteeing, sub 100 millisecond access to data. That'd be pretty awesome, but it's going to require automation of geo-partitioning, right? Making sure data is close to users across that world. And it's going to need that API. It's going to need that REST interface, right? To actually interact with that. So ultimately, we just want a frictionless SQL API. And to us, that's, I think, the end goal of what CockroachDB Serverless. Now, okay, so great. That's us. That's our old world and our new world. And we applied new principles and said, these are our requirements. I implore you to think about what you have today. How is it distributed? And then how do you actually meet some of the requirements as noted kind of here in terms of like, what does serverless actually mean? And if we think about these kind of 9 requirements on the left-hand side, you could start to apply these to whatever it is you have and whatever it is you're building and say, great, how do these concepts then apply to me as a vendor of a serverless CRM or whatever it is that you're actually building out there, right? So I think that's like kind of key takeaway number one. We have a blog post that talks about all these things as well. If you're interested in more, we definitely get that to you. So that's what we built with serverless. And so without kind of getting too deep into commercial, what we're doing, let me just show you what we did to our software to make this happen. Let's get into the architecture a little bit. And again, if you have any questions, please along the way, chat and QA is really great. So thank you. So when I think about a database and I think about the things that we build, a database is really comprised of 3 layers. Every database, right? It's basically there's a language. Hopefully, well, there's SQL. There's I don't know. There's different languages that people use for other databases, whatever. And at the bottom layer, it's storage, because ultimately what we're doing is we're just putting data to disk. That's really what's happening. We have to physically write stuff somewhere, right? There's a storage layer. And between that is execution. Execution's tricky. It's complicated. This is where the magic happens when I select star from where X equals Y. Like that's execution, right? Joins and views and indexes. That's all in the execution layer. It's pretty complicated. But database can really be generalized into those 3 things. Now, when you start to think about a distributed database, it's a little bit different, because ultimately the distribution, the replication of data and distribution is where things get very different, right? Because in an old world database, you synchronize data between different locations. In the new world, you're using something called distributed consensus. We're writing in 3 different places. All 2 of those 3 or 3 of those 5 or 5 of those 7, they have to actually commit, right? We need quorum when we write. This is a distributed concept. If you're not familiar with Raft, Raft is a very important distributed consensus protocol. There's also Paxos. Go check those things out. And we're talking about distributed consensus and replication of data across these things, right? Because we're talking about truly a distributed system, but the execution layer has to be rethought as well, because now we're thinking about how we distribute kind of not just in a single instance, but like across many different instances in a distributed system, right? And so in a distributed system, the database gets a little bit more complicated because this nature of it, right? This distributed nature of what we're doing. So let's start with the language. So number one, right? Cockroach is a PostgreSQL compatible. This is a relational database, referential integrity, normalization, secondary indexes, but it's important for serverless to kind of decrease this complexity, yet enable like all that agility you had with your old world relational data model. Like, how do I do, we can do online schema changes because we are distributed. We don't have to take things down and bring it back, right? We can upgrade the entire system that way. Guarantee referential integrity is a big deal, right? Thinking about data and your data model in a distributed system is fundamentally different than our old world. Like in the old world, we thought about the logical model of data, right? We thought about, tables and referential integrity and how they relate, one-to-many relationships, all those things. In the distributed world, you have to think about where data lives, because the speed at which people can get it, or the failure domains you want to survive, right? You have to think about again, speed and resilience are that physical side of the world, right? And so that's the thing. So let's start at the storage layer to just talk about some of the things that we've changed in Cockroach to make sure that we are really serverless. And this really comes back to the multi-tenant nature of what we're doing, because you'll see as we tease out the architecture, the trick to actually building a serverless application is to tease out those things that are ephemeral versus those things that can't be, those things that are tied to storage, if you will, right? And so the storage layer is very different than the ephemeral nature of execution, right? And that's really the trick to what we've done here, right? So in the storage layer in Cockroach, every table in Cockroach ultimately at the storage layer is stored in KV pairs. It's just this big monolithic logical key space. We use something called Pebble. It's actually we built it ourselves. It's in Go. It's kind of like rocks, but actually optimized for kind of more of a distributed environment, right? But ultimately, every table is just this huge logical key space. Let me just explain kind of what that means. So every table has a primary key. And when we store things in Cockroach, the K is basically the table name, what the index is, the key, and then a column name. And then the value is the value for that particular column, right? And so We do this all underneath the covers, and it's a KV store. Ultimately, this gets represented to everybody who just uses our database as a relational database. But we do this because it allows us to do some things in terms of how we distribute data, how we basically scale the database out. How we basically break down these huge tables into something called ranges. You can think of them as shards, right? But this allows us to keep order within that context, right? So let's just give a quick little example of this. Here's a table called dogs, ID, name, and weight. ID is obviously the primary key here. Here's a couple of entries, right? And so this is the old world relational. We still do the same thing. Underneath the covers, this is what Cockroach does. We basically take each one of these entries, and each one of them is going to turn into 2 entries in the KV store at the storage layer. Dog is the name of the table. There's the key, there's the column name, and then there's the value Carl, weight 10.1. And we do this for each one of the rows, okay? So that's great. So what happens when I have this kind of big, huge, we're gonna have a shared storage layer. We'll show you the architecture, but in the concept of a serverless kind of database or a serverless anything, remember, we're gonna have an ephemeral nature, stuff that can just go away easily without anything. And then we're gonna have a storage layer. We're gonna create one big shared storage layer for everybody. So what we've done in Cockroach is we said, look at, we're going to basically, if we have this kind of monolithic stored KV pairs, what we're doing is we're going to add a tenant to the key. So this person's database, Andy Kimball, one of our engineers here, brilliant, and he's come up with a lot of this architecture. We're going to append his name, basically. So all of the Andy K records, if we put them in order in the KV start, they're all going to be together. Now we know that those records are there. All the ranges in that range, all the very different segments of that belong to them. And that's how we get this multi-tenant nature, right? And this allows us to basically secure access to those ranges to only particular users, right? This table now belongs to the tenant. This record, this KV pair belongs to the tenant called Andy K. Now, listen, we codify this underneath the covers. It doesn't exactly look like this. This is all, this is an abstraction of what we're doing, but this is basically how we made the storage layer multi-tenant, right? Because we can now separate out each user in each one of these things. So let's talk a little bit about replication distribution, right? So again, we have this big monolithic key space. We have, tenants now sorted, and there's different things like Andy's records are here, Jim's records, JP's records, Tommy's records, right? They're all kind of in order now, right? And so what we do is when we basically take these ranges and we take this big thing, we're breaking it down into these ranges. They're 512 megabit ranges. And we're doing this all underneath the covers. Now, these ranges are small so that we can actually move them around really quickly. They allow us to they're very efficient in terms of how we actually do this compute. Now, when you actually have these ranges, what you need to do is we inserted this index structure so we can locate ranges. This is very much like a B tree. So you can imagine like, Andy K's records from A to Z are here in the yellow thing. Andy K's records from L to P are in the middle, right? And so we basically have this like an index that shows us where all the data is at the storage layer, because we have to actually kind of identify where these things are. Think of these things as shards, right? So where we're manually doing shards of a database, we're automating all of this underneath the covers. And we call them ranges in CockroachDB. Now, as I was talking about, we use Raft. Raft allows us to kind of have these atomic writes and consistent reads to the database. Raft is a distributed consensus algorithm. And what it's really comprises of is it's a very chatty protocol. So there's a lot of communication between these 3 Raft groups. The Raft groups right now, so think about each range as a Raft group. And there's an odd number of replicas. And when we write to this group, 2 of 3 have to commit. We have consensus, we have quorum, right? And so that's really allows us to get these kind of consensus, these consistent things. Now, there's a special member called the leader that allows us to get that kind of these atomic rights, right? It always has like the most up-to-date and the exact right information. And then there's some followers that actually that do this. Now, if you want a really good explanation of Raft, go check out the Secret Lives of Data, the THESECRET of data, Secret Lives of Data spelled out.com. There's a great explanation of how Raft works. But this, like I said, like once we commit to the Raft leader makes sure the followers are in order and we can actually commit a record. But Raft is allowing us to basically now distribute this data across various different places. Again, the secret lies at data.com. So you go check this out. So when we place data in Cockroach, we're basically placing it across multiple different nodes. So we're going to write it in 3 different places. Okay, so we're going to place the first range in 3 nodes, second range, 4 nodes, right? So we basically distributed this stuff so that it's even from a storage point of view. It's actually pretty important down below, but remember, each one of these ranges belongs to a person now, right? So let's just talk about how this is now implemented, right? So this gets a little bit more into the architecture, kind of how this works, and a little bit more into the serverless concepts now, right? So in a single cluster, we had one logical database. So each node in Cockroach, here we have CockroachDB node 1 with the 4 layers, right? And it's running on a SQL pod in Kubernetes. A lot of people run us in Kubernetes. In fact, CockroachDB dedicated, we run all this on Kubernetes. We have massive, huge clusters of Kubernetes. We've become Kubernetes experts around here pretty much. So, but what we're seeing is the storage is tied to the execution and the language. Each node completely comprises all of the different layers. It's one atomic unit is the entirety of the database, right? And what we have is we have one single cluster, one logical database. Any one of these nodes can service reads and writes. Every node is an endpoint, right? And it's going to be able to find the data across multiple different nodes, as kind of related here. Like there's 4 nodes, right? But this is the kind of same thing. But inside, we've actually said these are the different layers of capability within the database itself. Okay, so what we've done to actually make our database serverless is we've basically decoupled the SQL execution from the storage. SQL execution is ephemeral. It doesn't need any sort of like memory to do what it needs to do. It just needs to do what it does. It's stateless. Whereas storage and replication and what's going underneath, that's stateful, right? I need to know where that data is all the time. It can't just disappear. And when it does, how do I get it back? Right. And so if you think about that, and if you're familiar with Kubernetes, you know, when we think about stateful and all those sort of things, we think about stateful sets and that sort of stuff. That's what we're using to basically maintain storage. And each one of those, remember, each one of those nodes is connected to disk and everything else, right? So what we've done is we've separated the SQL layer, the execution, language, all this stuff from the storage layer. And the storage layer is now shared across multiple different tenants, hundreds of clusters. Gosh, man, there's thousands of clusters, right? But each kind of consumer of this has their own virtual clusters. So it's kind of like, great, I own my own virtual cluster. And it's got, 3 instances of SQL execution. So this is basically the pattern I feel is happening all over the place. Separate the ephemeral nature of what you do from that needs state. Scale the ephemeral nature, yet still drive kind of the storage layer and make that kind of, consistent and stateful. And I think defining your software into these 2 kind of sides of things is the architectural pattern that I think is going to emerge in terms of how we actually start to design software so we can actually automate basically how we scale these things out. So let's get into it a little bit more. So in CockroachDB Serverless today, if you want to go spin up a cluster, you can go to our website, you can spin up a cluster. What you're going to get is a virtual cluster. It's going to look like kind of virtual cluster 2 to start. You basically have an endpoint that's speaks SQL, it's doing the execution, it's using the storage layer underneath. Different clusters for each customer can have, or each tenant can have, different sizes, right? And what we do is we basically, spend these things out. Like if you think about, this is 3 availability zones, think about it as 3 Kubernetes clusters, right? And then we're just spinning up tenants and we're just placing them in various different clusters, and they have access to all that storage and replication underneath, because that's kind of one single storage layer virtually across these three different availability zones. Now, we can survive the failure of an entire AZ because, well, we still have 2 of 3 in other places, right? That sort of stuff, right? So we get this resilient nature of Cockroach still comes through. What we've done and what we had to do to understand where each of the tenants was is we introduced a proxy layer. We basically just have a load balancer. Load balancer is connecting to one of these proxies. The proxies know where tenants are. It has basically kind of a manifest, if you will, and it says, oh, the tenant is in this one. I have a tenant here, or I have a tenant over in AZ2. It knows the address of how to actually access these things. So now each one of the proxies, I can actually access tenant 1 because it knows tenant 1 is here, here, and here, and it can distribute queries across those 3 different endpoints equally. Okay, so I'm scaling, right? And I'm using these proxies to actually understand where these things are And I just have this generic load balancer in front of it that's basically now spreading out the workload across various different proxies then working as their own internal kind of distribution and understanding of where the SQL execution, these ephemeral pods live. So scale in CockroachDB Serverless is really kind of accomplished at 2 layers, right? Number one, the storage cluster just use this native distribution, the range splitting, right? As things grow, we just start to split ranges. It gets bigger and bigger. There's a deep dive into how CockroachDB works, and I can show you how that works in a wholly other video. But like, we can get data volume pretty easily. Scale is quite different, right? Because with scale, for transactional scale, it's a little bit different because volume of data doesn't really go up and down a whole lot. It just grows usually with the database, right? But transactional like volume is elastic. I might have a lot of users in the morning and maybe at night for whatever application it is. And then, in the middle of the day, there's very low usage. Well, I don't want to get paid for all that, right? So we need to scale like this usage, the transactional volume, right? Because there's spikes in traffic. And I want to spin down to dormant use so I don't have to pay for those things. That's all kind of accomplished through these ephemeral SQL pods, right? And what we've done is we've built an autoscaler. An autoscaler basically, it monitors the CPU load for every pod in the cluster, and then basically calculates 2 metrics: average CPU and peak CPU over the last 5 minutes. If we need more capacity, we'll spin up more SQL pods. If we don't, if we're going lower on capacity, we spin things down. How do we do that, right? And that's really the trick here. And I think that's where, this to me is the combination of all things that I love in life, or I guess in tech, and that's database and Kubernetes. Like, we're using Kubernetes extensively to actually do all of this. And this is kind of a nice little use case, or kind of a case study in how to use Kubernetes in an interesting way to do this, right? To get serverless, right? So here we have tenant 1. They have, the current load requires 3 different SQL pods, right? Because the amount of execution that's going on needs 3 pods. Like, that's the throughput that's going through. So it's kind of like middle range capacity, right? That's this little chart up here to the left, right? Now, in each one of these clusters that's running in 3 different availability zones, we have pods that are assigned to tenant, but we have these hot pods. Basically, they're instances, they're SQL pods that are up and running that aren't assigned to anybody. They're just there. They're waiting. It allows us to kind of get these things going very fast. I don't have to spin up a new pod. It's just there, and it's unassigned, right? So when capacity goes up, right, the capacity bar has gone up, I can actually, the proxy is going to understand this. It's going to say, hey, man, I can't handle this load. I need another one. It just goes into this pool of hot pods, takes something that was assigned and assigns it to tenant 1. I now have scaled ephemerally, auto-scaled now up the amount of pods that I need for this particular user. Storage and replication is just scaling the same way it's always done. It just gets bigger and bigger and bigger, but the SQL execution, the transactional side of it is actually changing, and we're scaling up. Okay, so then when I come back to steady state, and over the last 5 minutes, and we thought about this, autoscale is actually going to say, hey, man, I don't need this pod anymore. Throw it back into the clean pod pool, clean it up, throw it back and leave it unassigned. So take it out of the manifest so I don't have that thing. Great, I'm back to where I was. So I'm using this concept of hot pods where we basically say it's assigned or unassigned or whatever this is, and we can just actually roll these things out. So what happens when I come down to 0? Kill them all. Kill all the pods. Put them all back in the pool. And so that we can spin down to 0 so that, all the while in the back end, we're rating the amount of usage for each particular tenant. And now we know that, well, we don't have to charge them for any compute that they didn't use. And so underneath the covers, we can now spin down to 0. But when they come back, right, I can take one of these hot pods and bring it back very, very quickly, right? So I've spun down to 0, right? But as soon as I come back, a query comes through for that particular tenant, right? Like, Jim's birthday application database cluster. Well, I can get that thing going up really, really quick. It wakes up and I just spin up one of these hot pods, right? So for the first one, it takes, I forget how long it is. I believe it's under 100 milliseconds to get that thing going. But after that, you're good to go, and your queries are being answered really, really quickly. So that's what we're doing. We do this all auto scaled, spins up and down. And so you can actually go and use a serverless cluster right now. Right now it is single region. We're building out a multi-region for this. but we do have a generous free tier. We're rating everything in terms of of your usage. It's free forever. It's free every month up to 5 gigabytes of storage, and then 250 million request units. Now, a request unit is interesting. It's an abstraction of a transaction, basically. So all transactions are not equal. Some are more complex than others. And so that's our way of doing that. There's a lot more information about that on our website, in our docs and everything. You can go check that out. But really, it is pay as you go. And the free tier is pretty generous, a pretty decent sized application on that. But it's actually doing all this kind of back end stuff so that you are not getting charged for anything you don't use. We've implemented something called a sped limit on this. So this comes back to how you think about getting these things out there and making it consumption based. I don't think people like stuff that just runs wild and I get charged for, and in the end of the month I get this surprise bill for thousands of dollars. We actually put something called a spend limit in this, so you're never going to pay over your spend. We'll always regulate compute even when things are dormant, always below that, or even if you're trying to go above it, we'll regulate up to a particular spend limit. Now, okay, so what does that mean? Well, some workloads are pretty steady state all month long. That's scenario one. Some of them have like regular kind of cadence of peak usage. Maybe on the weekends I'm just big. Well, the total amount of kind of the area, the derivative, if you will, underneath that curve is 250 million RUs. And we're going to keep that to that particular thing. Maybe you use all of it in day one on scenario 3. Well, we're going to ensure that you have at least 8.6 or so million request units for every day of the month for the rest of the month. So you aren't going to spin down to 0. You can't even use the thing anymore. We're going to reserve that you have enough over the course of the time that you have that set. So really the kind of, serverless is out there. You can use it today. And that's kind of the architecture of how we built the thing. So it's really out there to get familiar with SQL, CockroachDB. I've been building applications on it. I like building on these no-code apps. Actually, they all hook up to it. Remember, this is just Postgres, so the Postgres driver should work with this. It's kind of like Postgres, but better. You don't have to worry about managing the database. It's resilient. It's scaling. It's doing this autoscaling. I'm only paying for what I use, right? So it's kind of one of these areas where if you're using Postgres, you could actually just go out and use Cockroach. So there's a question that came through. Will multi-region support for serverless require you to pick the regions you want, or will it just route a request to the nearest region? Great question. So when you implement any sort of distributed system across multiple different regions, the application instance and how it actually accesses a particular endpoint, an endpoint is still an address. And so really it depends on how you implement that in your application or whatever that's going to be. So you're just going to choose an endpoint. I believe when we come out with multi-region, I am not sure, don't quote me. From what I understand, we're going to have 3 regions across the planet, and you'll have those endpoints as things that you can actually connect to. Now, underneath the covers, it doesn't matter, right? Because underneath the covers, Cockroach is smart enough to find it's one single logical database across multiple different regions. So you're going to be able to access any data that's living in any region. One of the tricks to that is, how do we automate the movement of data between the various different regions so that if one user is connecting their data, say they're in Sydney and they're hitting the eastern, the node endpoint, but their data was in, say, the United States, do we automatically move their data to them? All of that is in progress. So complicated problems to solve. We're working on all that. And so stay tuned. Multi-region is not that far away. And right now, I believe in the first version, we'll have just the set number of regions. Picking them or not, I think it'll be an implementation detail. And so that's all coming soon. It's a great question, though. So I'm pretty excited for multi-region because now you're just getting a Postgres database that doesn't die and scales not just the number of transactions in a single region, but will also scale across multiple different regions across the whole planet. That's pretty awesome. So thanks for that question. Because ultimately for us, it's like, how do we take out these operations? How do we eliminate the need to do scale or upgrade? How do we eliminate downtime? And to me, the future is serverless. And honestly, I think the cloud paradigm gets really interesting when we get to that point. So there weren't any questions along the way. I hope this was valuable. I tried to get a little bit into the details of how things work here, how we think about things. And I think the big takeaway for me is teasing away, the ephemeral nature of your application and what needs to be ephemeral from those things that need to have state. Scaling them in different ways is the trick to, I think, building serverless apps and thinking about your own application. How do you actually apply, some of these serverless principles? Checking out the serverless principles, and I think we have a blog post that talks about those generically, honestly. So that is, I think I said it's like 35 minutes of content. It's about right. So unless there's any questions, I wanted to thank everybody for joining us today. I hope this was valuable. We're pretty excited about this stuff. I think this is kind of the future of where a lot of stuff actually moves. I think it'll get easier and easier over time. But go explore this stuff. Try CockroachDB Serverless. Reach out to us if you have any questions. And I want to thank everybody for joining. So thanks, everybody. Have a great day.